Hey guys, welcome back to the next video. In this video, we are going to talk about describing how to achieve high availability by using multiple availability zones. Now, as you can see over here, this is one of the topics or the skills which we're going to talk about. Now, do remember that there are a lot of points here which I'll just address it very quickly. It's not like something which we have never seen it before. We have seen it before in the previous videos. So I'm just going to reiterate the points to answer this question. So here it is asking us to achieve high availability using multiple availability zone. And you know what is a availability zone, right? Availability zones are physical, distinct, isolated data centers, which is part of a region. And it is also has a physical isolated connection like power, cooling, networking, ensuring if there is a like data center failure, it doesn't impact the other data center because that's going to have its own separate power, cooling, and networking. Now, the AZs are connected in terms of low latency, high speed networking links. So the AZs can have a data transfer between themselves, and they can also communicate or connect between AZs between different regions. So I will be talking about that later point of time in the latency session. I'll be showing you how that actually works. Next one is like high availability architecture for multiple AZs over here. So you can distribute requests across multiple AZs, like to ensure high availability. You can deploy critical resources like EC2 instances, RDS database services, load balancing services can be deployed across multi-availability zone, which gives you a little freedom towards working, confidently saying that at least one availability zone would be available in case of a disaster. Now, in terms of the failover and redundancy is going to be there because in case of any failure on one availability zone, the other availability zone can automatically take over, ensuring no disruption of applications is available. That's why we see most of the locations or the regions has three availability zones. Two of them will be your actual backup. Like for example, you will be actually replicating your data across two availability zones by yourself. And even one of that fails, there is the third availability zone which automatically fails over, and that is done by AWS. So that's the reason why you have three availability zones by default on every regions. The next one is load balancing. Now, AWS services like Elastic Load Balancer can automatically distribute, traffic across multiple availability zones, improving the performance and the ability of serving customers. In terms of when you configure AWS services and its availability, high availability across availability zones, first one is EC2. EC2 is the EC2 instance, Elastic Cloud Compute. So you can create multiple instances across each availability zone. So when you're creating instances, there is an option over there which lets you select which availability zone you want to create the instances on. So for example, if you see that I've chosen that this particular instance should be installed on the 1F availability zone, the other one should be installed on 1D availability zone. So you can simply, select this option while you create it by just going to edit on the network setting, and here you can select your preferred subnet, which basically points to different availability zones. So by default, the default VPC has default subnets, which basically is configured for each and every availability zones, which is already available. But if you want to configure your own VPC, you can also do that. But make sure that you allocate, subnets for each availability zone so that it can be chosen at time of creating services like these when you're doing your own stuff. So another thing is about auto scaling. We will talk about auto scaling later point of time, but auto scaling is also where you can actually choose multi availability zone for scaling your application automatically. To launch new instance in a healthy availability zone where the one which is having a problem will not be impacted by creating new instances. In terms of elastic load balancer can also do a cross availability zone load balancing, which means that the elastic load balancer can distribute traffic to multiple AZs. Okay, so it itself will be hosted on multiple AZs, and as well as it can distribute the traffic to multiple AZs. And once it determines that one AZ is down because that server wouldn't be accessible, then it will stop sending requests to that particular server or EC2 instance, which is on the failed availability zone. The next one is like RDS, relational database services, where you can use this option of for any database offering which is offered by AWS. You have option of selecting multi-AZs RDS deployment, where primary database is deployed to one AZ and standby replica is deployed to another AZ. So AWS automatically replicates the data synchronization and performs automatic failover in case of primary instances fails. Now the next service which has availability zone is S3, where S3 is AZ resilient storage, which means that S3 is designed for high availability and durability across multiple AZs by default. So your data is automatically replicated across multiple AZs, ensuring access even if one of the AZ goes down. And you don't see that option as well. It is on which availability zone. You cannot see that because it is already spread across multiple availability zone by default. Now, one of the key components of high availability setup across multiple AZs is that you have application layer, which is multi-AZ deployment of compute nodes. And you have database layer, multi availability zone for your database, like which is RDS or something like that. Storage layer, S3 EFS is also has a similar capability of deploying it in multiple availability zone. And your load balancing capability, like cross availability zone load balancing with the elastic load balancer. So all these are the key components which may come in your questions. So they would ask you if there is a failure in availability zone, which of this following would be part of your failover of a high availability failover. So a couple of this, it would be a multiple option choosing question, or it would be a single option choosing question. But you have to remember, these are the layers which is covered as part of a high availability setup. Now, in terms of benefits, we can talk about fault tolerant, which is a benefit over here, which lets you with zero downtime experience, where your customer will not be knowing about the switch over to a new AZ. And you have the automatic failover, where in which it is not waiting for you to initiate a failover from a failed one to the working one. Load distribution, making sure that your elastic load balancer understands a failed availability zone and transfer the load. Low latency network, wherein which every availability zone has its own network connection between each other, so that the the latency of data transfer, if there is any, won't be affecting. And in terms of increased resilience, it talks about basically application is more resilient to disruption, allowing for a consistent uptime of your application, which is crucial for your mission critical workload. In terms of examples, web tier, database tier, storage, DNS routing is all coming under high availability. So you don't really have to worry about any of these instances going wrong or any of this tier going wrong if you have set it up through AWS. In terms of cost consideration, EC2 instances running instance on multiple AZs means that more instances increase compute cost. Data transfer, as in like if you want to transfer data between multiple AZs that is within the same region, is free. But it is also important to consider other costs like storage, scaling, and monitoring services which you involve for your high availability setup. But anyways, if you buy your own infrastructure for high availability, it's going to be cost incurring. So there's no escape on that. So thank you again for watching this video. I hope that you understood and you're able to answer the questions in towards this topic. I'll see you on the next video.